Hello all, let's start section 1.4. In 1.4 we are covering using the definitions of trigonometric functions. The first thing that we will discuss in this section is about reciprocal identities, correct? Reciprocal identities. I already discussed with you in section 1.3 that there are three main trigonometric functions and there are three reciprocal of them, which sine theta, if I talk about sine theta number one, sine theta, the reciprocal for sine theta was cosecant theta, correct? I explain it this way there for you, but right now I'll give you another notation also that soon we are using this notation also when we are dealing with mainly when we do proofs on the trig equations or identities, when we check if both sides of equal. Later in next chapter you will see that one. We use it, but it's really important to know both ways. Look, sine theta was y over r, correct? And I told you the reciprocal for sine theta is cosecant theta, which is r over y, correct? Remember this. Now, I will explain it this way. Sine theta, and I will show a little bit proof here for you. Sine theta, because I am telling it's the reciprocal of cosecant is the reciprocal of sine, then I can write 1 over cosecant theta, correct? Let's see, in your book mentions sine theta is equal 1 over cosecant theta, or the other way you can say cosecant theta equals 1 over sine theta. Which way you go, this way or this way? But let me show you in a quick proof here that yes, it's right. Correct? Sine theta in terms of x, y, and r, sine theta is y over r. Correct? This one means equals to 1 over, if I replace the cosecant theta, the value on this side, you see r over y, 1 over r over y, and if I simplify the right side, correct, then I can say y over y. Is this equal to this? We want to prove it, correct? It's a complex fraction. Then what we do, we keep the numerator, which is 1 over 1, times the reciprocal of denominator y over r. Easily, you can say that y over r is equal y over r. A quick proof. It's not a kind of official proof, but just I want to show it to you that yes, this reciprocal identity, both of them, that they put for you, it's a correct thing. You saw it here by proof. Y over r equals y over r. Then the first one you have to memorize. Sine theta equals 1 over cosecant theta, or cosecant theta equals 1 over sine theta, which is the same as sine theta over y over r or r over y, correct? Number two, same way. I don't want to do this proof for all of them. You just saw the first one, which works. Cosine theta equals cosine. What was the reciprocal of cosine? The reciprocal of cosine was secant. It means you can write cosine theta equals 1 over secant theta, or the other way, secant theta equals 1 over what? Cosine theta. Last one, tangent theta. The reciprocal of tangent was cotangent. Then you can write tangent theta equals 1 over cotangent theta, or the other way you can say cotangent theta equals 1 over tangent theta. These three with this side, we call them reciprocal identities. Correct? We will use it in future because in future you are not using too much x, y, and r. Usually we deal with identities. Starting now, you have to memorize them. Correct? Actually, not memorize them, to understand them. We just, when we say the reciprocal of cosine is secant, the mathematical notation is this, right? Cosine theta equals 1 over secant theta. Or the reciprocal of secant is cosine, then the mathematical notation is this, right? Secant theta equals 1 over cosine theta. Correct? Now, let's do an example using this reciprocal identities. Example number 1. Find cosine theta. Find cosine theta given that secant theta equals 5 over 3. Okay, secant is given, they're asking you to find cosine. The easy way, because I know, I will show you, but please do not do it this way because they're here telling you using the reciprocal identity, correct? I'll show the easy way also for you. Both ways are easy, but you will see the other way also. We know the relation that cosine theta equals 1 over secant theta reciprocal identity. Now, secant is given to us. We replace this value here, correct? Then I can say cosine theta equals 1 over 5 over 3. And we simplify this. It means 1 over 1 times 3 over 5, which gives me cosine theta equals 3 over 5. We are done. The other way, using 1.3, we know that cosine theta equals x over r, correct? And secant theta equals r over x, correct? R over x is given to you, correct? If you flip it, then you can easily write cosine theta equals 3 over 5. The same answer that you see on the left side. But because in this section, they are asking you to use the reciprocal identities because they want to see that you can slowly memorize them or understand them, we go this way. Other than that, this way is really easy, the right side, correct? Let's do another example. Example number 2. Find sine theta. Find sine theta given that cosecant theta cosecant theta equals negative square root of 12 over 2. Very easy, but we deal here a little bit with kind of simplifying the square root of 12, because those of you that you have a stronger base of algebra, as soon as you look at to the given value, the square root of 12, you can say, wait a minute, I can break square root of 12 to two numbers. Correct? I can simplify this. I'll circle it with the red. You can simplify this, right? Because it's given in a format that it's not simplified, but you can simplify that definitely. Correct? Because 12 is 4 times 3. I'll show it to you, but let me first use the reciprocal identity to find sine theta. Correct? Okay, we know sine theta, now we know very well, equals 1 over cosecant theta. Let's bring this value and plug it here in the denominator. Then you can say sine theta equals 1 over negative square root of 12 over what? Over 2. To simplify more, it's equal 1 over 1 times negative 2 over square root of 12. Correct? Now, it means sine theta equals to negative 2 over square root of what? 12. But you see, instead of a square root of, I have to do here a little bit explain algebra for you. Sometimes you have a number under the radical that you can simplify it. For example, this one, a square root of 12. Can I rewrite the square root of 12 as a square root of 4 times 3? Why I'm doing that? Because I know 4 has a perfect square root. It can go out of the square root, correct? It means the square root of 4 is 2 and 3 stays under the square root sign or under the radical. In other meaning, square root of 12 means 2 radical 3. Let's bring this value and plug in our denominator. Then I can say sine theta equals, I'll keep the negative, and the numerator I have 2. Denominator, instead of square root of 12, I can write 2 radical 3. Correct? Now, I can cancel these two. Then sine theta equals negative 1 over radical 3. But remember, I told you in previous section and the section before that we cannot have a radical sign in this book in the denominator. We rationalize the denominator, right? Then I will multiply this fraction by radical 3 over radical 3 to rationalize the denominator, which gives me sine theta equals negative 1 times radical 3 gives you radical 3 over radical 3 times radical 3 gives you 3. That's your answer. And I will do here radical 3 over radical 3. Please avoid this new algebra that I see some students are doing. They cancel out like this. They say, oh, square root of 1. Oh, the answer is 1. You cannot do that, right? One of the 3 is under the square root and the other one is outside. You cannot do this. If it was like this, the square root of 3 over 3, yes, you can simplify here. But here, only one of them is under the radical. You cannot do that. If you do this, you are doing a wrong math. Please be careful focus on your algebra, because sometimes I'm explaining the algebra part a little bit for you, but I cannot do it all the time, correct? You have to use your algebra that you learned before. Next topic that we will discuss in this section is signs of functions value, or I will put both names for you. Signs of function values, or in a simple language you can say signs of trig functions. What does it mean? The 6 trigonometric functions, we should know what are their signs if our angle is in a standard position. To do this, I'll try to draw here for you a good what we call it, a good system of coordinate here, and explain everything for you. And your book and presentation that you see in Canvas, it's given as a table. I don't like it, because why you should memorize that table? It's not necessary to memorize that table, but if we work, if we show you here this way, it's easy for you to understand everything, correct? This is your x-axis, this is your y-axis, here is 0. Let's talk about this system of coordinate system, or rectangular coordinate system. Rectangular coordinate system, you know it from algebra, that has 4 quadrants. We call this one quadrant number 1. We call this one quadrant number 2. We call this one quadrant number 3. We call this one quadrant number 4. Now, all of us from algebra, we know that any point in a quadrant has 2 coordinates. For example, if I draw here a point, this point has a coordinates of x and also has a coordinates of what? Y. For example, if I name here 3 and name here 3, the coordinates of this point is 3, 3. Correct? You see both of them as positive numbers, because in quadrant 1, x is positive and y is positive, correct? Then I'll put some general forms for you. I just explained it. I'll erase back this. Let's talk in general, correct? In quadrant number 1, always your x is positive, correct? And your y is positive. I'll do this way. In your book, they show it for you. X greater than 0, y greater than 0 means x is positive, y is positive, correct? Also, you know that you always need an r, and I discuss it in section 1.3. When you find r equals a square root of, for example, any number that we did before, the square root of a number is actually positive, negative, right? You can end up with r equals plus minus 5, correct? But which number you use, positive 5 or negative 5? I told you, you use always positive. Why? Because the distance is always positive. Distance cannot be negative. It means here, when I'm talking, in all 4 quadrants, your r is positive. Now, why I'm doing this? I'm doing this to explain something. I will do it here in the side for you, only for quadrant 1, But for the others, I will just write that you can see what the table talks about, correct? Look, if my theta, if my angle is in quadrant 1, correct? Then sine of theta, which is y over r, it means positive over positive gives you a positive number. It means I can say in quadrant number 1, sine is positive. If the angle in a standard form lies in quadrant 1, then the sign for the sine function is positive. It's interesting. The sign for the sine function is positive. Let's talk about cosine. Cosine theta means x over r, right? Here, I will draw a little bit for you. You can see this is your x, this is your y, this is your r, if you don't remember lecture 1.3, correct? X over r, it means x is again positive in this quadrant, r is positive, it means your cosine is also positive in quadrant 1. Tangent theta means y over x. It means again positive over positive, which gives you positive. Okay, if this 3 is positive, their reciprocals are definitely positive also, right? First one, cosecant theta, because it's the reciprocal of sine, it means r over y. It means again positive over positive. It's also positive in quadrant 1. Correct? Secant theta, because it's the reciprocal of cosine, it means r over x. It means positive over positive. It gives you also positive. Cotangent theta, which is the reciprocal of tangent theta, it means x over y. It's also positive over positive, which gives you positive. Then, from here, I can write even a sentence here for you. In quadrant 1, all 6 trig functions are positive. Let's see in quadrant number 2. What's happening in quadrant number 2? In quadrant number 2, you see the value of x and the value of y. Let's see the sign. In quadrant number 2, your x is negative, right? You are on this side. But still your y is what? Positive, correct? And r is still positive, correct? Now, if I work again here on this side, I just erase these signs. I can talk about quadrant 2. I can find all the signs of these trig functions in quadrant 2. Once you do it by yourself, like this, the way that I did, there is no need to memorize. If I talk about the presentation, if you open my presentation in Canvas, on slide 6, they give you a sign chart for the 6 trigonometric functions and 4 quadrants. You don't need to memorize them because you will learn like this. It's easily, you can understand what's going on. Now, sine theta means y over r. You see your y in quadrant 2 is positive, correct? R is positive. It means sine is again positive. Cosine is x over r. It means positive over negative will gives you negative. Tangent is y over x, means positive over negative, which gives you negative. Cosecant is the reciprocal of sine. It means positive, or the other way, positive over positive gives you positive. Secant is the reciprocal of x. I know it should be negative, and if you see rarely, positive over negative gives you negative. Cotangent negative over positive, negative. You see, now I can talk about quadrant number 2. In quadrant number 2, cosine, only sine and cosecant, you see they are positive, the rest is negative. In quadrant number 2, sine and sine theta and cosecant theta are positive only, the rest is negative. Correct? I will not do the same thing with quadrant 3 and 4. I just showed two of them. How you can find those signs. Use the right side of my lecture. Do it for quadrant number 3 and quadrant number 4 as a practice. I only write here for you what's happening in quadrant 3. In quadrant 3, you will find and you can see that tangent theta and cotangent theta are positive. The rest is negative. Correct? In quadrant number 4, cosine theta and its reciprocal, which is secant theta, are positive. Correct? That's the meaning of that table that you have in slide 6 of presentation. You should know which quadrant your angle is, and when you are talking about trig functions of that angle, you should focus on the sign also, right? You should focus on the sign also. Now, let's do an example. Example number 1 for this part. Determine the signs of the trig functions, the signs of trig functions of an angle in a standard position with the given measure. A, they give you 87 degrees. Okay. They give you an angle theta, which is, let's name it theta, that's 87 degrees. They are asking you only don't find the trig functions for 87. We are not doing yet that one, because after you did unit circle, we will start with that. Only talk about the sign of trig functions about this, correct? To do that, after few practice, even you don't need to draw, but because you are new now, try to draw this angle in a standard position, correct? Practice that. Draw your rectangular coordinate system. This is X, this is Y. Try to draw this angle 87. Of course, the initial side is on the x-axis, on the positive side. The vertex is 0, 0, correct? Now, your terminal sides, because it's 87 degree, it should be less than 90, correct? It goes really close, like here. It's like this, a straight line. This is 87 degree. Now, you see, this is your quadrant 1, correct? Your angle lies in quadrant 1. Then let's see what that says. Look at this chart that I draw for you. If your angle is in quadrant 1, all 6 trig functions are positive. Okay, the answer for part A is all 6 trig functions for 87 degree is, or you can say all 6 trig functions sines. You can add here also sine. For 87 degree is positive. In part B, they give you 300 degree. Part B, 300 degrees. Again, try to draw, understand where is 300 degrees and which quadrant your angle actually lies. Correct? X, Y. Again, initial side on the x-axis. Positive 300. If you go to here 90, come here 180, go here 270. 300 will come in quadrant where? In quadrant 3 actually. Correct? This is your theta. Your angle lies in quadrant, not 3, sorry, quadrant number 4. Correct? In quadrant number 4. Now, what was the sign distribution in quadrant number 4? In quadrant number 4, cosine and secant are positive, the rest is negative. You can write as an answer cosine of 300 degree and cosecant, secant of 300 degrees are positive, sine of 300, tangent of 300, cosecant of 300, and cotangent of 300 degree, or you can say in English language, the rest is negative, correct? Which way you want to write? Correct? The rest is negative. This was examples about, of course, there are more that you can do. These were examples about how to know the sign of the trig functions based on which quadrant that your angle lies. Correct? This is really a long lecture, and next one I have to talk about the range. I will do that here in this part, then I'll stop the video and I do part 2 for you because I don't want to give you really a long lecture. I want to separate it in 2 parts, correct? And this part, even I cannot talk too much in this part because I can talk too much about this part when we graph these trig functions, but at least because it's in the presentation, I want to explain it a little bit for you. I cannot do much for you. I can do a lot when we graph, but not now, correct? And this part of the lecture, we are talking about ranges of trigonometric functions. What does it mean? It means when you find the sine value of an angle or the cosine value of an angle, which values actually they can take, correct? I will write here for you, but I told you I cannot explain right now the reason for you, because you will see the reason and when we graph them, but at least you should understand, because if you do a mistake, if you calculate something, this lecture actually helps you a little bit, that you can see if your value is correct or not. Sine of an angle theta and cosine, let me put here and cosine of angle theta, correct, an angle theta, the range is they can take the values from -1 to 1. For example, if I ask you to find the sine, I'll do this example for you, of 45 degree. I know you don't have an idea what is the sine of 45 degree, but if you use your calculator, it gives you radical 2 over 2. You see, radical 2 over 2, for example, is a number between 1 and -1. Or you already saw that the sine of 90 degree was the sine of 90 degree was 1, correct? It cannot be more than 1. It's also a number between 1 and -1, correct? Tangent theta and cotangent theta of an angle theta, they can get values from -infinity to positive infinity. I will use here the open interval notation. Here I use the closed interval notation. But believe me, I'll bring this chart up the day that you work on the graph. And there you will laugh, you will see that yes, that was true, correct? Secant theta and cosecant theta, their range of values are from -infinity to -1 union 1 to infinity. That's the range that they can take. For time being, just try to memorize it this way. Later, when we do graphing, you don't need to memorize, you will understand what does it mean. Correct? I'll stop the lecture here. Even you will not see, I will not do problems on this because it's a lecture that came too early. It's not the time that we should talk about these range. Later we will talk about. I will stop the lecture here. Let's do an example, then I can stop the lecture for you, correct? Let's do an example because we talk about the sign of values also. Let's do an example and I'll stop the lecture here and I'll do another lecture for part 2. Let's do an example. Suppose that angle theta is in quadrant 2, and sine theta and sine of theta equals 2 over 3. Find the values, find the values of the other 5 of the other 5 trig functions. Here you have to focus on the sign of them also, correct? Your angle is in quadrant 2 in a standard position. You have an angle here in quadrant 2, whatever that angle is. This is x, this is y, this is your quadrant number 2. Your angle is here in quadrant number 2, correct? And the sine of your angle is given to you. Sine theta equals 2 over 3. They're asking you to find the other 6, the other 5. Based on the sign chart that I explained for you, in quadrant number 2, you saw that in quadrant number 2, sine and cosecant, which is the reciprocal of sine, they are positive, the rest is negative, correct? Now, sine theta equals 2 over 3, and I know sine theta equals 1 over cosecant theta using the reciprocal identity, which means 1 over 2 over 3, which gives me 1 over 1 times 3 over 2. It means 3 over 2. Then cosecant, sorry. Totally, I put opposite reciprocal identity. Here, I need to find cosecant. Cosecant theta equals 1 over sine theta, correct? We had this one as a reciprocal identity. It means 1 over 2 over 3. It means 3 over what? 2. Both signs are positive, correct? Because we know in quadrant number 2, these 2 is positive. For cosine theta, you need to know r again and x, correct? But x is not given to you. Look, sine theta equals 2 over 3. It means it's y over r. It means your y is 2, your r is 3, correct? Now, can I find the value of x? What was your main relation? R equals a square root of x squared plus y squared. Or even you can use this one. R squared equals x squared plus y squared, correct? If I use this one, I know the value of r, I can say 3 squared equals x squared plus y squared. It means 2 squared. Solve it for x. I can say 9 equals x squared plus 4. Subtract 4 from both sides. Then x squared equals 5. It means x is equal square root of 5. Correct? Plus minus. Now, should I use the plus sign or the minus sign? There are different ways. Some people, they just use radical 5 at the end of the problem. They are just their sign, but I like it the way that they explained it in your book. You can adjust even your sign right now. Your angle is in quadrant 2. The value of x in quadrant 2 is negative. We know that. Then I can say from here, x is equal negative radical 5. Okay, now I know x, now I know y, now I know r, and I know all reciprocal identities. Can I write the other 5? I already did one of them, the cosecant. Let's start with cosine. Cosine theta equals x over r, correct? It means your x is negative radical 5 over your r is 3. Secant theta equals 1 over cosine theta, which means 1 over negative radical 5 over 3, which gives you negative 3 over radical 5, and you can here rationalize it. It means secant theta equals negative 3 radical 5 over 5, correct? I already explained how to rationalize. Please don't complain. Go back to the video that I explained how to rationalize the denominator. Do it. Correct? Because I am just explaining once. Tan theta equals y over x. It means your y is already given to you as a 2. Your x is negative radical 5. Correct? If you rationalize, it gives you negative 2 radical 5 over 5. And if I know this value, I know cotangent theta, which is the reciprocal of tan theta. It means 1 over negative 2 radical 5 over 2 over 5. Simplify this one, which gives you negative 2 radical 5, negative 5 negative 5 over 2 radical 5. And you can rationalize it again here. Correct? I'll stop the lecture here. See you all in part 2 of section 1.4. Part 2 is really, really, really important. I'll start proving things for you. You have to focus on that because the proofs are not in my slides, and I think even they're not in your book. And part 2 of this video, we will talk about very important topic of trig, which we call it the Pythagorean identities. Stop the lecture and see you in part 2.